Okay, so what we will now do is we will try to get into the most basic and the most commonly used technique which is used for predictive analytics, and that is using regression models. There are other predictive analytics tools which you will learn through the course of the program, but regression model is the one which you are probably going to use most frequently. There are various categories of regression model. We'll start with the most simple one, the linear regression models, and gradually we will go on to the nonlinear regression models. So the first question we need to ask is, why do we need regression models? Predictive modeling. So what do we understand by predictive modeling? That in various cases you want to you want to say that what is going to happen in the future, and that you can do only when you understand what is happening right now. So there will be a variable of interest which you want to predict. And there are various kinds of examples which we can think of predictive modeling. We will build on those examples as we go along. And our main objective is, will we be able to say that tomorrow or the day after or next year, this is going to be the possible values of a particular outcome we are interested in. Okay. So to get into predictive models, I have to find out which are the factors that explain our variable of interest. Okay. So that's the first key thing which we want to do. And then we need to find out that what is the relationship or the difference between regression and correlation. So why are these three important? For predictive modeling, to predict any values of y, we need to find out the set of values of x, which we think are going to explain how y moves. Now this could have also been done by correlation, when we look at only y and a single x. But as I say, a single x, which means when we are looking at correlation, we are looking at a binary relationship, that how is y moving with x. But what we will be faced with is, how is y related to multiple values of x. And in that case, we will not be able to do correlation. In fact, what we should be able to say in those cases is, how is that a particular variable x1 affects y when all other variables are held at the same level. So we are only interested in one variable affecting y when all other variables are kept at the same level. What are the possible examples which we can think of predictive modeling? So example 1. What do we think will be India's energy consumption as GDP grows by 6.5%? Now, if we were to answer this question, we need to first find out that what are the factors that affect India's energy consumption. Well, GDP growth rate is certainly going to be one, because higher the GDP growth rate, which means more people will be better off. They would probably consume more energy. More industries will be in place. It is because more industries are in place, the GDP growth rate has gone up. And because more industries are in place, the energy consumptions will go up. So there could be multiple factors. Now we need to be able to pinpoint those factors, find out which factors are important and which factors are not, and then try to make a prediction that if one of those factors happens to be GDP growth rate, and if that grows up to 6.5% next year, what would be the India's energy consumption. Second example, this is an example which you will probably very frequently counter in analytics exercise, that what is the default probability. In this case, we are looking at default probability of a customer who will default on a housing loan. Now again, what are the possible factors? The possible factors is the customer's income has gone down, or it is possible that he has a sudden liquidity shock, he needs some more money which he doesn't have right now, or his health has broken down, or there could be various other factors because of which a customer is unable to pay on the housing loan commitment. So therefore, we may be interested in what is the probability that a customer will default on housing loans. We will try and see how does one do such kind of predictive modeling. The third example is, how many fatal road accidents will we have in Delhi if the traffic volume increases by 10%? Okay. First of all, why is this problem interesting? It could be of tremendous interest to insurance companies, because in the event of a fatal accident, all those people who are insured by the insured company has to make a payout, and they might want to recalculate the entire premium value and the actuarials based on this fact of how much they think the fatal accident is going to increase next year in Delhi, given that we expect the traffic volume to increase by a particular percentage. So these three are only some of the indicative examples which we have put through. There are various examples of regressions which we will go along, which we will try to do as we go along this course. So coming to the basic regression techniques. So let's start with simple versus multiple regression. What we mean by simple and multiple regression is basically whether you have one variable or you have multiple variables. So you have an y variable, which is the variable of interest, and you may want to look at how is y affected by a single variable. That would be simple regression. If you are interested in how is y affected by a set of variables, that will be multiple regression. There is no simple or a complex structure in regression. The regression structure is the same. The simple and multiple regression are simple terms to be able to distinguish between these two. There is another distinction which one should keep in mind, and that is between linear and nonlinear regression. Okay. What we are doing right now is the linear regression. Later on, we will do nonlinear regression. At this stage, it is important just to know what linear regression is. When we talk about linear regression, we mean is y related to the parameters linearly. I will explain what the parameters are. When we talk about nonlinear regression, we talk about is y non-linearly related to the parameters of the model. So let's kind of get down to some basic regression models. This is exactly how your regression model will look like. Y is a variable of interest. Beta 0, beta 1, beta 2 and all others, these are your parameters. So beta 0 is a parameter, beta 1 is a parameter, beta 2 is a parameter, and beta k is a parameter. If we were doing simple regressions, we would only have beta 0 plus beta 1x, so only one variable. If we are doing multiple regressions, you have multiple variables, x1, x2, all the way up to xk. What exactly is this u term? This is the error term, which means whenever we are trying to do a regression, we will never get an exact fit. There will be some amount of error, and u captures all the error term. So any form of regression which you do will be of this particular format. Now, is this a linear regression? Yes, it looks like linear regression, and it is indeed a linear regression because y is linearly linked to beta 0, beta 1 and beta 2. This is not to be confused with y linear with x1, x2 and xk. This is not a linear regression because y equals to beta 0 plus beta 1 x1. It is a linear regression because y is equals to beta 0 plus beta 1 plus beta 2. These parameters are linear. For example, instead of this regression equation, if we had beta 1 x1 square, that will not make it a non-linear regression. That will still continue to be a linear regression because it is linearly dependent on beta 0 and beta 1. So that's one very important distinction which we need to keep in mind. Now, what exactly do we do in terms of the regression? How do we start the problem? First, we have to define y. So if we go back to the examples which we are giving, and let's pick up the last example, how many fatal road accidents will be there if the number of motor vehicles in the streets increase by 10% next year, then y is the number of fatal accidents. What is beta 0? That's a parameter which is constant. What is x1? x1 in our example will be the number of motor vehicles on the streets of Delhi. What is x2? It could be multiple other variables, multiple other factors. For example, x2 could be the number of traffic police on duty next year. x3, x4 could be similarly other variables. So y, how do we define y? We define y as the number of fatal accidents. How do we identify x? We know one of them is number of cars or motor vehicles on the street. x2 and x3 are the other variables are number of traffic police on duty, so on and so forth. Once we have done that, we will try and estimate this particular equation. And once we have estimated that, it's time to interpret. Estimation is the regression technique. Interpretation is an output which we will have in front of us, and we will try and interpret the various particular values. Okay. So that is exactly what the regression technique is going to be all about. Now, before I get into the estimation equation, let me try and visually kind of present what exactly are we trying to do in a regression analysis. That is exactly how are we planning to estimate the values beta 0, beta 1, beta 2, etc. In other words, if we end up with an equation, the number of road accidents is equal to 10, that is the value of beta 0, plus 1, which is the value of beta 1, times x1, from where did I get these numbers 10 and 1? Once I have got these numbers 10 and 1, I will be in a position to interpret them. So right now what I will try and do is show you the basic structure or give you the basic concepts as to how one gets those values beta 0 and beta 1. So let's start with first how the data is going to be organized. So we would have a variable of interest, that is y, and we will have a variable x. Okay. So if typically the data will be organized in this following way, you have multiple values of y. So let's say there is going to be, one particular value is y equals to 10, x equals to 22, y equals to 12, x equals to 23, y equals to 8, x equals to 17, and that's the way. Somewhere maybe you might have an y of 24, x equals to 31. So these are the number of observations which you have. Okay. So before we start getting into any kind of regression analysis, the first thing which is I think is always advisable is to be able to plot the scatter and look for the pattern. So what do we mean by plot the scatter? So supposing we had plotted it on an xy plane. So this is my x and this is my y. Let's try and plot these observations. The first one is y equals to 10, x equals to 22. So suppose this is the first observation. Then the second observation is 12 and 23. So it's roughly out here. The third observation is 8 and 17. It's here. Then you have a 24 and 31. It's probably somewhere around here. So basically, if you plot all of them, you are going to get scatters all over the place. Okay, so that's how the observations will look like. Now, what you're trying to do in regression is trying to find the best possible line or curve that represents most of these points. Okay, so is this line the best possible line? Is this curve the best possible fit we can have, or is this line? That's what regression is going to tell us. And it's going to do a simple, the way we get those parameters estimates of beta 0 and beta 1 is by doing a very, very simple exercise. It tries to look at every observation, looks at how far is it from the proposed line. So what I'm trying to do is I'm trying to find out how close is a particular point to the line. So this point is this distance away. If there was an observation here, so this will be, this much distance away. If you look at one more observation, which is this, then it is this distance away. Basically, whether you look at this one, this or this, all of them have a particular error from the line. So the whole idea of generating the parameters is to find out that particular line which has the minimum error distance. So there is a technique which is going to find out the line with the minimum error distance, and what we call it as the ordinary least square or OLS estimates. So it's like ordinary least square error estimates. We don't call it OLSE for error, we just call it ordinary least square errors. So whenever we try and do a regression, the most simple estimates which comes up from the regressions are the OLS estimates. What are the advantages of the OLS estimate? The basic advantage of the OLS estimate is that those parameters are pretty accurate representation. Accurate in terms of they're unbiased, which means if you get an estimation, it is not overestimating the number of accidents or underestimating the number of accidents. It is trying to give an unbiased estimate. And those are also somewhat the true estimates. We'll actually look at now at a data, an example, and see how do we do the regression, how is the regression output, and how does one interpret the regression. Okay. So we will be moving to an actual data with the way the data is structured, try to probably convert it and get into the regression mode.